The story of the solar panel is one of human curiosity, scientific discovery, and the pursuit of clean, renewable energy. It begins with a fascination for light itself and how sunlight, one of the most abundant natural resources on Earth, could be harnessed to create power. Today, solar panels cover rooftops, fields, deserts, and even spacecraft. But their journey to becoming one of the most important technologies of our age was long and filled with incremental discoveries. The origins of solar panel technology can be traced back to the early 19th century. In 1839, a French physicist named Alexandre Edmond Becquerel made a remarkable discovery known as the photovoltaic effect. At just 19 years old, while working with his father in a laboratory, Becquerel experimented with an electrolytic cell made of metal electrodes in a conductive solution. He noticed that when light struck the electrodes, it produced a small but measurable electric current. This was the first time anyone had demonstrated that light could directly generate electricity. Although his experiments were far from practical power generation, they planted the seed of an idea that light energy could be converted into electrical energy. Throughout the mid to late 1800s, scientists continued to investigate the properties of light and electricity. In 1873, Willoughby Smith discovered that selenium, a chemical element, was sensitive to light and could change its electrical conductivity when exposed to it. This discovery led to further experiments, and by 1876, William Grylls Adams and Richard Evans Day demonstrated that selenium produced electricity when exposed to light, confirming the photovoltaic effect in a solid material. Charles Fritts, an American inventor, then created the first working solar cell in 1883 by coating selenium with a thin layer of gold to form junctions that captured sunlight. His selenium solar cells only had an efficiency of about 1%, meaning they converted just a small fraction of sunlight into electricity. But they were the first true solar panels. These early attempts were groundbreaking, but limited by the technology of the time. Electricity was still a relatively new phenomenon, and society was just beginning to harness it for practical use. The late 19th and early 20th centuries saw rapid advancements in electrical power generation from coal, oil, and eventually natural gas, which were far cheaper and more efficient than solar energy. As a result, solar power was largely ignored as impractical, although scientists continued to study the photovoltaic effect in laboratories. The story of the solar panel advanced significantly in the mid-20th century, thanks to the development of semiconductors. In 1941, Russell Ohl, an engineer at Bell Laboratories, patented the first modern solar cell using silicon. Silicon had emerged as an important material for electronics because of its properties as a semiconductor, allowing it to conduct electricity under certain conditions. Ohl discovered that when impurities were added to silicon in a process called doping, it created a junction that responded strongly to sunlight. This was the foundation of the silicon photovoltaic cell, the building block of modern solar panels. In 1954, Bell Laboratories unveiled the first practical silicon solar cell, capable of converting sunlight into electricity at around 6% efficiency. This was a revolutionary breakthrough. For the first time, solar panels could generate enough power to run everyday electrical devices. The event was celebrated widely, and newspapers heralded the beginning of a new era in which sunlight could be turned into usable electricity. However, the early silicon cells were extremely expensive to produce, costing hundreds of dollars per watt, far beyond the reach of commercial or residential applications. Where solar panels first found real success was not on Earth, but in space. The 1950s and 1960s marked the beginning of the space race, and satellites required reliable sources of power. Batteries alone were insufficient for long missions, and solar panels offered a continuous renewable source of energy as long as the satellite was in sunlight. In 1958, the Vanguard 1 satellite became the first spacecraft to use solar panels, and it remained in orbit for decades. Solar technology became the standard power source for satellites, spacecraft, and space stations, driving significant investment and development in the technology. On Earth, however, solar panels remained prohibitively expensive. Throughout the 1960s and 1970s, research focused on reducing costs and improving efficiency. The oil crisis of the 1970s sparked renewed interest in alternative energy sources, including solar power, as countries sought to reduce dependence on fossil fuels. Governments and private companies invested in solar research, leading to improved manufacturing techniques and gradual cost reductions. Silicon solar cells achieved efficiencies of 10% to 15%, making them more practical, though still costly compared to conventional electricity generation. By the 1980s and 1990s, solar technology began slowly spreading into commercial and residential use. Small-scale solar panels powered calculators, remote communication stations, and off-grid homes. Larger solar farms were constructed in sunny regions, though they remained rare and expensive. Public interest in renewable energy grew, fueled by environmental awareness and concerns about pollution, climate change, and the depletion of fossil fuels. During this period, Japan, Germany, and the United States became leaders in solar research and development, implementing government subsidies and programs to encourage adoption. A major turning point came in the early 2000s as manufacturing costs began to fall dramatically, driven by technological innovation and mass production. Advances in silicon processing, new thin film technologies, and global competition, particularly from manufacturers in China, made solar panels far more affordable. Governments introduced feed-in tariffs, tax incentives, and renewable energy targets, further accelerating adoption. Efficiency improvements also continued, with panels reaching over 20% efficiency in some cases. Solar panels became a common sight on rooftops around the world, symbolizing the shift toward clean energy. They allowed homeowners to generate their own electricity, reduce utility bills, and even sell excess power back to the grid in some regions. Solar farms expanded across deserts, fields, and even floating platforms on water, contributing significant amounts of renewable electricity to national grids. Today, solar panels are at the heart of the global transition to renewable energy. They are a key technology in the fight against climate change, offering a sustainable alternative to fossil fuels. Modern panels are more efficient, durable, and versatile than ever before. Some are integrated directly into building materials, such as solar roof tiles and windows. Others are flexible, lightweight, and portable, capable of being rolled up or carried for outdoor use. Research is ongoing into next-generation solar technologies, including perovskite cells, multi-junction cells, and transparent solar panels, which promise even higher efficiencies and broader applications. The impact of solar panels extends beyond electricity generation. They represent a profound shift in how humanity interacts with energy, decentralizing power production and empowering individuals, communities, and nations to harness a limitless natural resource. They have also brought electricity to remote villages, transforming lives by providing light, refrigeration, communication, and access to information where traditional power grids do not reach. The story of solar panels is still being written. As costs continue to fall and efficiency rises, solar energy is expected to play an even larger role in the world's energy mix, alongside wind, hydropower, and other renewable technologies. Solar power is helping create a cleaner, more sustainable future. What began as a curious laboratory experiment in the 19th century has grown into a global industry, reshaping economies, societies, and the planet itself. From Becquerel's first discovery of the photovoltaic effect to the solar farms powering entire cities, the journey of the solar panel is a testament to human ingenuity, persistence, and the desire to harness the natural world for progress. It reflects the challenges and triumphs of scientific exploration, the intersection of technology and society, and the ongoing quest to solve some of the greatest challenges of our time. The solar panel is more than just a piece of technology. It is a symbol of hope for a future powered by clean energy. It tells the story of how light itself, the most abundant form of energy in the universe, can be captured, transformed, and used to power human civilization. And as the technology continues to evolve, the solar panel remains a shining example of how curiosity and innovation can change the world.